So for this question, it says prove proposition, which is let x be any set and let D be the discrete metric on x. Let the sequence be a sequence of points in x and let x be a point in x. Then the sequence x refers to x with respect to the discrete metrics if and only if there exists in big N greater or equal to m such that x of n is equal to n for all n greater or equal to n. So let's take our assumption here. Let x be an arbitrary set such that the discrete metric is be on x as well as small x is in big X as a metric space. So I want to show that the sequence converging to x implies that there exists big N greater or equal to m such that x of n is equal to x for all n greater or equal to big N. So for sake of contradiction, let's assume that there exists no big N greater or equal to m such that x of n is equal to x for all n greater or equal to n. Well, if this n doesn't exist, right, this such that x of n is equal to x, this implies that x of n is not equal to x for all n, not in natural numbers. This implies that the limit of n of the discrete case of x of n and x is not equal to 0, which is contradiction, right? Because xn is supposed to converge to x. I also want to show if exists n greater or equal to m such that x of n is equal to x for all n greater or equal to n, this implies that the sequence x of n converges to x in the discrete metric. Sorry, I should have stated that here. Well, I think it's on here as well, the assumption. So exists n greater or equal to m such that x of n is equal to x implies, for all n greater or equal to n implies that x is equal to x of n plus 1, x of n plus 2, which basically implies for all natural numbers that the limit of as n approaches infinity, right, because n plus 2, n plus 3, n plus whatever, however arbitrary big you want n plus anything to be, will be equal to x, right, which is going to equal to 0. Thus, this is true.